So hello everyone, I'd like to welcome you all to the latest installment of Hydrocarbon Processing's Refined View. Now today we have a very special guest joining us, who is John Wasson, is the founder and president of Wasson-ECE Instrumentation. Today we're going to be speaking with him about his recent article, Monitor Parts Per Billion Monomer Impurities in Catalyst Poisons with Process Gas Chromatographs Mass Spectrometers, or GCMS. Have to say that 5 times fast. So this article is a feature that is in the September issue of Hydrocarbon Processing magazine. It is open access, so I want to encourage all of you to visit hydrocarbonprocessing.com. You can access the article in the magazine tab. To do that, click on the magazine tab, and under that, go to the current issue, and you can find the article there. So with that, I would like to welcome in our special guest, John. John, how are you doing today?
I'm doing excellently. Good morning. Good to be with you.
Excellent. Well, again, thanks so much for a couple minutes of your time. Now, before we do dive into the article that you wrote, can you let the viewers know a little bit more about Wasson-ECE Instrumentation and your role with the company?
Okay. So my company, the company I founded in 1986, actually finds its way back to Carl Instruments in California. That's the company I started, or excuse me, joined right out of school. 1981, they actually invented the valve for GC. That was long before there was a Valco. So they built their own GC. They employed all of these little magical valving techniques that you can use with GC, and those GCs were sold only applicated. So customers would come to us and they'd say, this is our list of analytes, these are the concentration ranges. Build us a GC that will do that. So they didn't want to learn chromatography to that depth themselves. They just wanted essentially a turnkey solution. So we did that, and that's how I learned the basics of applicated GC and what that concept was to deliver turnkey solutions rather than bare vanilla boxes. And so that company was bought by Hawk, and then that was no fun. So we started this company in 1986 and took the same thesis forward, applicated turnkey systems, only instead of building our own GC, we partnered up with HP at that time, 5890s and later 6890s, 7890s, and now we're doing 8890s. But the philosophy is always the same. Tell us what you want to measure, concentration ranges, and we'll build you up a system to do that. And so that's been our bread and butter since 1986. We're in 45 countries around the world. We have wholly owned subsidiaries in Prague, Czech Republic, in Singapore, and we have 2 outposts, one in Japan and one in Venezuela. So that's us in a nutshell. And then getting to process GC.
Excellent. Perfect. So with that, let's go ahead and dive right into the article. Now, you start your article by talking about the need for high quality ethylene streams. So just to kind of get the ball rolling, why are high purity ethylene streams so important?
Okay. High purity ethylene or propylene, both are world-class monomers used around the world in high volume, high dollar amounts. So you want to make sure that those monomers are very high purity before they go into the polymerization catalyst. Those catalysts are often platinum based, very expensive. You can imagine how many cubic feet are in a reactor that's 100 feet tall. And I remember 20 years ago, the catalyst inside was $1,000 per cubic foot. So it's very important that the polymer come out right and the catalyst be protected from catalyst poisons. So oxygenate, sulfurs, things like that would irreversibly poison those catalysts. So in order to maximize their uptime and not have to regen or replace those catalysts, they want to monitor the monomer composition very carefully down in the part per billion range so that they know that they're getting top dollar for their monomer product. And then on the flip side, they're getting maximum usage out of their polymerization catalysts. So it's very important to know exactly what's in that pipe down to the part per billion level.
Yeah, that's the truth. Now, one of the real interesting parts I found was the last part of your article where you detail Analytical Challenger company conducted for a leading North American petrochemical producer. So, can you provide the viewers a synopsis on this and some of the findings that you gathered?
Sure. So we had a customer down in the Houston area that was looking at ethylene and came to us with a challenge. they said that we want to analyze all of these components that are on our hit list. And right now we have a number of other types of process GCs being employed, but even then they're still short. They still can't get everybody that's on the list. And so we looked at the list and they said, yeah, we can. We said, yeah, we can kind of do that. So that's good. But that really wasn't the challenge. The big challenge was on page 2. So we turned the page and they said, we need to have maximum flexibility for this analyzer going into the future. Somebody goes nuts with a chalkboard and all of a sudden they're inventing some new impurity that they think could possibly be in their stream, needs to be checked for. So now all of a sudden they want to add that to the list. So can we have an analyzer that does everybody on our hit list now and have maximum flexibility going into the future? So we took that challenge and we had two basics, FID, PDHID. FID is going to do the hydrocarbons, of course. PDHID, post-discharge helium ionization detector. That's going to do fixed gases, especially CO and CO2 down to part per billion. And then we need to get all of these sulfurs, all these oxygenates, and other these mystery compounds that are going to pop up in the future. So for that, we employed mass spec. So mass spectrometry gives you excellent sensitivity. It's got excellent linearity. It's going to go down to the part per billion range. Mass spec has the ability to, if you will, look into the peaks and find out what the peaks are made of, so to speak. And that way you get confirmation. So there's no guesswork. It's more than just retention time. But you can look inside the peak and say, okay, this is exactly what I'm looking at. I know this is the peak of interest. The last thing it does is it provides maximum flexibility, except for helium and hydrogen. We can analyze really for everything else in the sample, present and in the future. So if we have to add something to the list, we just turn on different ions, and then we can address different analytes as the analytical challenge evolves over the future. So the GCMS is just an excellent complement. We use Agilent's 5977B mass spectrometer. That's the most popular mass spec in the world. So we find to be very rugged. Yes, you can run mass spec 24/7. We've actually been doing it for a number of years. And you can imagine laboratory GC mass specs with big 100 vial carousels on top. In fact, they're running virtually continuously anyway. So we've been able to bring those three technologies, put them into one specific analyzer and have a lot of analytes checked off the list and also the ability to flex into the future.
Excellent. Yeah, and I do want to get back to that technology here in just a minute. Let's go talk a little bit more about your company in general. So you've been doing GC applications for 35 years, and now are you just getting into process GCs?
Okay, so that's a popular misconception, Lee, because actually we've been doing process GC for the past 25 years. So we started out doing the lab applications. Those were very successful. People would come to us and they'd say, okay, we know what you can do with these, at that time, 5890 GCs. We need to have the same chromatography online. So actually, we've been doing process GC for 25 years. The world's most capable process GC, as a matter of fact. We knew what the target was, the same thing that we were doing in the laboratory, capillary columns, precise temperature programming, pressure programming. We put an extra oven on the 58, 68, and 78, 90s so that we've got two ovens. We built the sample system. We put the whole ensemble in a big cabinet, purge, pressurized heat, air condition the cabinet, fitted out so that it is hazardous area rated, class 1, div 2. So we've been doing that for 25 years, and we just wanted to come up with our own process GC. We knew exactly what the target was, and it needed to be a smaller unit, less expensive. It needed to be classical format, which is wall mount, not big cabinet with an air conditioner stuck on the side. So we've been doing GC for 25 years. We knew exactly what the target was. We just had to build our own hardware and software, with the exception of the mass spec, which we said was Agilent. Everything else is ours inside the box. And I think that history of being able to do turnkey solutions, understanding chromatography, really guaranteeing the analysis as a turnkey solution, fit right into the process GC market. So we've actually have an extensive history in process GC. Now it's new with the Eclipse family. It's our format, it's our box, it's our software.
Excellent. And that's a great segue to my next question because, yeah, I did want you to talk a little bit more about your Eclipse line of process analyzers. I guess the big question is what makes that Eclipse line different?
So Eclipse Line is different in that the principal objective was capillary columns and temperature programmability. If you look at classical process GCs nowadays, they have a little bit of an issue with temperature programmable. It's really not their forte. Their philosophy is class 1 div 2 with the door open and the door closed. And we had 25 years of experience of being class 1 div 2 with the door closed. But when you switch philosophies and say we're not rated or we're power off when the door opens, then that lets you switch towards a true convection oven. So we've got the U.S. patent on what we call the micro convection oven. These are built out of machined refractory. They are toroids, and essentially they wrap around each capillary column. So now you've got two temperature programmable ovens, two isothermal ovens, and the wide array of detectors. We can do also vacuum ultraviolet detector. We can do mass spec, PDHID, FID, TCD. So that's what makes us different because we've got these true micro convection ovens and we can do real temperature programming and pressure programming just like the lab systems. Now you can go to your laboratory and say, okay, these are the analysis that we're doing in the lab. I can port them now online because we have a completely different format or platform with which to do the chromatography. So that's what makes them different. These are excellent tools for capillary columns, temperature, pressure programming, all kinds of exotic detectors. It's lab quality stuff. Now it's online.
All right, now I do want to talk more about GCMS. Now, your company does offer online GCMS using mass spectrometry. So the big question, what is the potential for online GCMS?
I think the potential's huge. And we were starting out and we kind of were dabbling in this, and a lot of people are coming around to it. They have the mass spec experience. They know the capability of mass spec. Again, it's that confirmation. It's a no guesswork. It's part per billion sensitivity. It's flexibility for all kinds of analytes. So people are coming around and saying, you know what, the mass spec technology is powerful. And in fact, in the case of Agilent's 5977B, they're quite robust. They do last a long time. They are, in fact, workhorses. So if I want something that's very broad ranging, for example, in the case of ethylene and propylene, we have two columns. One column is for light components. The other column is for medium and heavier components. We switch them in and out as a function of method. Now you've got everybody that can really range from very light components, like I say, everything except helium and hydrogen. Everything beyond that can be done with one analyzer. And again, you've got that confirmation, you've got the flexibility. If you hook a library up to it, you can run across an unknown peak, feed that to the library. So, and not only do they become workhorses in, shall we say, known environments, but they're also very strong going out into point studies inside a plant or a pilot. You can put them online. Now you've got GC mass spec directly connected to your sample lines running 24/7. So it gives you a lot of flexibility for the investigatory work that needs to be done. We have put them on wheels, actually, on big dollies, sample system attached, so you can actually move them around a pilot or move them around a plant, hook up the power, hook up the DCS, bring in the sample lines, sit there on station for several months, do all your work, and then go on to the next stop. So now you've got that research capability that's now online 24/7, always looking at every analysis. Nothing slips by when you're online.
Wave of the future. That's
That's
where it's
right.
going. Well, I tell you what, John, this has been a really interesting talk. I think we've only scratched the surface of this. So if the viewers are interested in what we're talking about and these kind of technologies, where's a place that they can turn to find more information, primarily about what you guys offer?
Okay. So our website is out there, Wasson, WASSON hyphen ECE That has a big write-up on the Eclipse. There's contact information there, and Lee, we are one of the few remaining companies in North America that actually answers the telephone when it rings. So if you have a hot question or something, go ahead and give us a call. Phone number's on there, and we can talk directly to an applications chemist. So that's where the bulk of our information is. And like I say, email us, phone us, whatever you like, and engage the topic, and let's see where we go.
Yeah, that's a dying thing. Usually you listen to an automated robot or something.
Yeah, it gives you a million reasons why they'd rather you just go to the website. Actually, we'd rather talk to you than have you go to the website. So we appreciate a phone call, actually.
Excellent. Well, again, John, we really can't thank you enough for your time today to discuss this important topic that's in our industry. And lastly, of course, we want to thank all of you for joining us for another installment of Hydrocarbon Processing's Refined View. Thanks again for joining us.
Thanks.